Hi everyone, welcome to Altair's presentation for Rapid Multibody Analysis from Altair. So here today we have Joyce Tang and myself, Andreas Dimitriadis. So we are both application engineers within the support team at Altair UK. So our job is to sort of look after customers, support with sort of technical support queries, train customers, and complete some projects with them as well. On top of that, we also run the academic program within Altair UK, so some of you may be familiar with our names from before. So just a little agenda for today, what we're going to run through. So I'll have a little sort of introduction to Altair, who we are as a company, what we have to offer. Then Joyce will run through rapid multibody analysis with MotionSolve, and then we'll have some polls and a Q&A at the end. So firstly, a little bit about Altair. So as of the year 2019, we're roughly around the sort of $500 million mark. Within the company, we have about sort of 3,000 engineers, scientists, and creative thinkers, and we've been around for quite a while. We've been around since 1985. We were founded, and we're currently headquartered in Troy in the US. And since then, we've grown a fair bit. So we've now got around 11,000 customers globally. We've got 86 offices across 25 countries around the globe, and an ever-growing list of Altair products and partner products. So it's somewhere clear of around 150 at the moment. In terms of the solutions that we have to offer, so we cover quite a few, but there's two that we're going to focus on. So we've got the physics simulation side of things, so that'd be implicit and explicit FEA, high and low frequency electromagnetics, CFD, obviously multi-body dynamics, etc. The list goes on. And obviously to access these solvers, we have a whole host of design, modeling, and visualization tools, pre and post processors to help you extract the most from our tool set. And on top of that, there's data analytics tools, Internet of Things, and HPC products as well. In terms of the customers, we're sort of quite broad in terms of the industry verticals that we're part of. So obviously we have a big focus in automotive. That's sort of where Altair started out at. But we spread into aerospace, into obviously education, energy, financial services, material suppliers, etc. But specifically from, I guess, a student standpoint, you'll see it here some quite large graduate recruiters. So obviously having Altair in your CV is always quite a handy thing. If you look at JLR, McLaren, Honda, Boeing, Airbus, particularly for my student days, remember them as some big recruiters, BAE Systems, etc. So a whole host of sort of opportunities out there for customers using our tools. Why maybe you'd like to use Altair? So we have best-in-class data analytics and streamed data visualization, but to focus more maybe from a student aspect, you've got a global domain and simulation expertise to come from. So it's not just one office in the UK accessing these tools, it's the whole of Altair who has this expertise which you can access. We are the leader in optimization technology. So OptiStruct, our optimization structural code, has existed since I think 1990. So we come with sort of a host of optimization techniques and manufacturing constraints to ensure that your optimization ends up with a part that is feasible to manufacture. Obviously, we're a leader in HPC technology. We've been working on that for quite a while. A nice thing that, again, may be of use to you is that we have open architecture solutions. So you can access basically any CAD package that you've got. Apologies. Any CAD package, so be it Autodesk Inventor, CATIA, NX, you can import into our software, and it's the same for the solvers. So if you happen to be solving with Abacus or Dyna or whatever it may be, you can pre-process using our tools and then solve using whatever solver you have access to. We do have a unique licensing model, which would ensure that you never really run out of licenses, but when it comes to student competitions, I will detail later why this, I guess, doesn't really matter too much to you. In terms of the industries that we're in, again, aerospace, architecture, automotive, making sort of full use of our software. And it means that, whatever discipline you're interested in at university, there will be an industry out there that would be of interest to you. In terms of the applications, again, key ones probably here for you being structures, implicit and explicit, systems modeling, multi-physics, industrial design, fluids and thermal and electromagnetics may be key to some of the technologies you would wish to access. So I'm going to pass it over to Joyce, who's going to take you through a rapid multi-body analysis demonstration.
Hi everyone, welcome. So thank you very much for the introduction, Andreas. Now that you have a good idea as to who Altair are, you might have heard of us before. We're not just the HyperMesh guide. So hopefully you can see from our broad suite of portfolio that we do much more than just topology optimization. And to start this next section, I'll be taking you through in looking at multi-body dynamics and the software that you can use in order to conduct this. So we'll do it in two parts. We'll go through looking at the model build itself, so using MotionView and MotionSolve, where I'll take you through the vehicle library wizard and looking at flex bodies. And then I'll also take you through Inspire Motion, where you can look at, understanding a rapid analysis of how you can connect all your different parts together, and then how you can actually take your multi-body dynamic analysis straight into a topology optimization. So how we can conduct an optimization based upon how our parts are being used. So as you know, I'm not too sure what everyone's CAE background is. Some of you might have used FEA before, some of you probably never encountered this before. So we'll go through exactly why it is that we should use MBD. So within the CAE workflows itself, we have three main sort of routes that you can go down. We can either look at using simulation to emulate real life scenarios. So this is where we understand how our product are being used, and we want to design for its intended purposes. The second way about it is, we can emulate physical tests. So for example, if you're going to be producing a car to be used that's roadworthy, we need to make sure that it's also crash-worthy. And in order to make sure that it fulfills these standards, it needs to be able to pass physical tests. So this is where we can start looking at designing to make sure that we can replicate standardizations and the different testing procedures. And then finally, last but not least, at times where if we don't really know how it's being used in real life, because maybe it's part of a huge assembly, or at times where we're not trying to replicate a physical test, this is when we can start looking at a multi-body dynamic analysis. MBD basically helps you look at mechanisms within your parts. So if you're looking at an assembly, you can look at a mechanism-derived analysis, and you can also look at your part assembly performance. So if it's a standalone product, obviously you understand exactly how it's being used. But say if it's, a control arm, a lower control arm from a suspension system, you probably want to know exactly where the attachment points should be and the strength that it's undergoing when being used. So just a little bit about the two products that I'll be introducing. So what you'll be able to see is that within the first demo, I take you through MotionView. Now, MotionView is the preprocessor, the place where you would set your model up. And MotionView is exactly, the GUI in which you would interact with and where you would, bring your CAD in to work upon. The same with Inspire Motion. Inspire Motion is a second GUI that you can also work with, but obviously based upon what it is you're looking at, you can choose between whether if you want to use MotionView or if you want to use Inspire Motion. Now, just because they're two different interfaces, they're two different GUI, it doesn't mean that, they would solve differently. Because what's actually being run in the background is our solver called MotionSolve. So within MotionSolve itself, this is basically the solver. You don't have any sort of interaction with it. It's the massive calculator in the background that does all of the simulation work for you, that does all the calculations after you've set it up. Hence, even though they look slightly different, or Inspire Motion is slightly easier to use than MotionView, this by no means means, the results you get are less accurate. It's just as accurate as our full-blown, complex MotionSolve solver that's used for MotionView setups as well. So let's start with looking at MotionView and MotionSolve. So within this part, obviously, we've just discussed, why it is that we should conduct an MBD analysis. We will understand the connecting mechanisms of our different vehicles. So I'll walk you through the library wizard itself. The fact is within MotionView, how it's different to our other products is the fact that you can make it as simple as you like, but you can make it as complex as you need it to be as well. So from simple to complex functionalities, either you can make it, a simple model, or you can make it fully parametric, where if you were to change one value, all of your other model sort of setup updates will change itself with respect to that change that you made within the parametric model. For those of you who already use HyperMesh, you'll be able to see that there is a seamless transition between HyperMesh and MotionView, where you can take one mesh model and just bring it straight into MotionView. So this enables, a really nice way of your FEA teams to work with your MBD teams, and there's an ease of organizing different system entities. So without further ado, I'm going to bring up my screen. So within this demo itself, what I'm going to do is show you exactly how you can access the assembly wizard, how you can build full vehicles, or maybe just the front end or the rear end of your vehicle, and then how you can take it through to then specifying and understanding how all your joints work and the forces generated from them. So when you start up MotionView, you will see that it looks a bit like this. So let me pull the right window in. So you'll see it looks a bit like this. For those of you who already use HyperMesh, you'll see it's quite similar in that it's got the same sort of setup, and you have a project browser at the side here. So you've got a project browser at the side. You have another taskbar of your different options. And also you have your actual menu icons at the top. Now, the way in which we would go about it is, because it's multidisciplinary, you have lots of different options that you can load in. So either we can start looking at the attachment wizards. You can look at the assembly wizards, and any sort of library wizard that you need to access, you set it here. Just so you know, you aren't just tied to looking at vehicles. You can start looking at a small truck or a car, a heavy truck, or two-wheeler. So if you're going to design for a bike, you can easily change your wizard library here. But for today's demo, what we're going to do is just show you the assembly wizard. So when you click on the assembly wizard, you'll see that you can specify a model type that you want to look at. So say if we want to look at the front end of the vehicle, you can then specify the driveline configuration. You can specify if it's a front or rear wheel drive. And then obviously you can select your other primary systems, so the vehicle body, your front subframe, the suspension system itself, what kind of configuration did you want it to be. There's 5 different options for you to choose from, and obviously you can choose the one that you're working with as well. And obviously with steering linkages, you can specify a type and powertrain as well. You can go through and do the same for the steering column and any sort of steering boost. Your suspension system, the front struts and stabilizer bars, you can specify if you want, if it's using inline joints or cylindrical joints. You can go through and set all of this up. For now, I'll just set all this as it is, and you'll see very quickly that it builds the front end of the vehicle for you. Now, straight after this, what you can do is either you can go through and bring in your own CAD to replace different parts. You can change these different hard point locations. And like we mentioned before about, using the well-organized different system entities, you can use it from here at this side itself in the project browser. So you can expand upon them and see, which graphics and which bodies belong to which system. So you can see within the suspension system itself, it refers to the knuckle, the lower control arm, the wheel, and the wheel hub. And like we said, either you can specify the mass and the inertial properties of these parts, so exactly, the way in which it would move, the coordinates of it as well. So either you can make it to follow a point that you've got, that you're using. And like we said, either you can make it fully parametric, so it refers to another point, or you can enter in the values itself. Now, once we see everything, we understand, all the different systems that we're working with, you can then attach an analysis. So within MotionView, you have a analysis wizard where you have the default standard ones that you might want to look at based upon the model that you have loaded in. So obviously you can start looking at a kinematics and compliance analysis, or you can start looking at the steering analysis. What it really cleverly does is it understands where your different map points are, and obviously you can change your vehicle parameters for the test itself. And you can go through and specify your test parameters as well, So the jumps, travel and ride, the rebound, travel, maximum longitudinal forces, you can change them all within this area. And you can see very quickly within motion view, it understands exactly where those points are and where to attach that test onto. So at this point here, what you can do is click run, and I can then save it in the specific folder. So if I was to bring in and save it here, we can call this demo 2 and just click run. And like with every solver, it will then tell you exactly what's going on, how far it is within the solve, and within a few seconds you can very quickly see the results of this setup. So let's let that run in the background. Now, if I can start another one to show you, you're not just tied down to looking at, the front end of the vehicle. What you can always do is start looking at full vehicles as well. So say if I go into the analysis or the model assembly wizard, we can start looking at integrating a full vehicle with a driver, or you can specify that driveline configuration. For now, I'll leave everything as default, but obviously you can go through and select a driver system as well. And the driver system is awesome because say if you wanted to understand the amount of power or the torque required to go through a certain road in a double lane change, you can easily specify that driver to overcome all of those different parameters. So you can see here we have a vehicle, and very quickly I can attach another analysis to it, and you can add a different event. So in this term, I can do a double lane change, do OK, and you can see it map out a road for this vehicle to follow. Now, this road isn't just held off for anything that's already built into the model. You can create your own events as well. So if you did want to, make your car do donuts, you can easily do that as well. So once we have this set up, then again, you can then go through and change your different vehicle parameters to make it more applicable to your vehicle itself. You can change the shell, the CAD, so any sort of CAD graphics that we already have. So these graphics, you can easily click on them and you can replace it with your own graphics as well. So these will be the points where you go through and you can make it refer to a different CAD graphic that you're looking at. So like we said, if I just run this in the background, I can call this car, and let's run it. Now if I can refer back to my previous model, this one's probably solved now. You see it's completed. So what I'm going to do is click animate. And very quickly, you can then do the post-processing on the other side of the screen for you. And if you were to click play, we can go through and specify the forces that we get from the different assemblies. And obviously, if we were to change the display, so if we did it by magnitude, if I did this, let's just do it as a, there we go. We can see the forces that the car will go through throughout its whole time in travel. And then the same can be done for this one again, where you can click on animate, and throughout this section itself, you can see exactly the behaviours in which this car would have to undergo in order to do a double lane change. And obviously through here, you can get all the results you need. Now, what's really nice is that built into Motion View and MotionSolve is the fact that you always get these reports with it. So with every sort of standard analysis, you can specify it to output the same set of results each time through a report template. So for instance, if I were to head back into this analysis, just by going into View Reports, you can see anything that you solve gets brought up here. So based upon that analysis that we just did at 12:16, I can click to load up the standard results, click OK, and you'll see that not only will it bring in all the different viewpoints of the vehicle that you might want to focus upon, but it also generates all the different graphs for you. So if we give this a second to just load, we can do the same with our car as well. So here you can see the car's pretty much coming to an end of doing a double lane change. And say if you wanted to understand the camber or the behaviour of certain aspects in your vehicle, very simply, analysis, view reports, and we can bring up the double lane change report as well. So if I click on OK, now you can see from this K and C analysis, from this one itself, we can go through and we can look at all of the different graphs. So you can look at the left wheel center, motion versus toe. So you can look at vertical displacement in the phase, so the toe angle, caster angle, camber angle. You can go through all of this and it will give you everything you need. So you can also then look at exactly how it is that you might want to optimize it to improve its performance and go through all of it here. Now, once you want to start looking at flex bodies, so flex bodies are different to what we would use in Motion View. So Motion View assumes everything's rigid, meaning that it won't deform when it's being used. Now, you would then start incorporating flex bodies into these different parts if you know for a fact that, you know, the force of it will change because your part will be undergoing significant deformation. That's when we want to start incorporating flex bodies. And very easily, you can click on flex body and you would just bring it in. There's lots of tutorials to show you how it is that you can do a flex prep. It's very easy to use. And one more thing that I wanted to show you is that, for instance, for anything that you're looking at, if you right click in model, you also get the optimization wizard. So let me just save this first. If I save this as a model, I should be able to show you how you can use the optimization wizard. So with the optimization wizard, if you say, you know, you wanted to change the hard point of your suspension systems, you can go through and specify exactly, you know, what it is you want to change. You can do all of these and just click add. And obviously if they're parametric, then you have to go through and make sure that they're not parametric, but obviously this is where you can go through to specify what it is you want to change. You can look at the nominal values, so where it's currently sat at, and you can optimize it for the different sort of values. So you can optimize it based upon its performance and take it through for an optimization itself. There's another tutorial online for this, which you can easily refer to. But yes, this is Motion View. In a nutshell, I obviously have only covered just a few of the many sort of complex functionalities that it can do. But do give this a go. And there's lots of tutorials online. If you go to help and go to help home, there's lots of tutorials in there which will show you exactly how you can go through and use this tool to design your FS vehicle. So if I can head back into my slides. But obviously with MotionSolve itself, it's capable of creating fully parametric models. This is where you want to, you know, use MotionSolve if you want to look at full vehicles and specialize on using flex bodies, then this is when you want to use Motion View. You can use it to predict your dynamic and kinematic responses. You can ensure that your desired product and system performances are met using the optimization wizard. And obviously, with the optimization wizard, you would optimize the performance of your moving parts. And MotionSolve itself also facilitates multidisciplinary collaboration across product platforms. So say if you wanted to couple this solver up to your CFD as well, you can easily do that with all of our suite of tools. Now for the next few minutes, I'm going to show you Inspire Motion. This is a tutorial that you can do online as well. It's myself that I've recorded a video for all of the students that you can follow. If you go to Altair University, you can also conduct this tutorial yourself. So, you know, we also have another second tool called Inspire Motion. And why is it that you want to use Inspire Motion? So compared to Motion View, I fully appreciate that because that's a full-blown MBD solver. And, you know, there might be some other tools that you might not be using, so it's quite complex. Inspire Motion is super user-friendly. It shows you a really nice workflow. And if you just wanted a very quick understanding of your connecting parts, you can obtain it very quickly here using Inspire Motion. It's an all-in-one GUI, so where you have your model set up, it will be set up in the same place as where it's solved, as well as where you would look at the results. It gives you very quick optimization ideas. So if you want to optimize it based upon how it's being used, you can do that. And you can easily carry it through for a structural analysis. So any sort of MBD analysis that you have, you can take it through straight through for FEA from the generated loads that you get. And it is a simplified version of Motion View. So you can't do flex bodies, So everything in Inspire Motion is assumed to be rigid. You can't do flex bodies in it. But what you can do is export decks from Inspire Motion to use within MotionView if you want to take it from a simple analysis to a more complex one. So if I can just show you this quick video on screen, I'll be showing exactly how you can create this motorcycle suspension part. You can see it's optimized design after having done dynamic analysis, and then you can validate it for its final design and strength validation. Okay. So very quickly, let me just show you that this is obviously the final design. And with the Force Explorer tools, you can see all of the forces that are generated from the actual animation. And now the way in which you would go to set it up is very quick and simple, and I'll show you exactly within the next few minutes. So you'll see within Inspire Motion, it looks fairly different to MotionView. Let me just make sure I have the right screen up. Here we go. So you'll see within Inspire, we work from a left to right workflow. Same again, we have our menu tools at the very top where you can look at geometry, structure, motion. So if you wanted to edit any sort of the geometry very quickly, these are some very good tools here that you can use. But within Motion, you can see from left to right would be the flow in which we would recommend you to use. So easily, if you have any sort of CAD part, I can drag and drop the CAD straight into Inspire to open up. And then through this aspect itself, you can see exactly what you're working with, how many parts you have, and it'll show everything here. So you can also tell it to calculate the mass of each part to see what you're working with, and if you're in the right unit. Just note that there is an internal units converter down at the bottom right corner where you can change it to what you want to work in. So the first thing I'm going to do is start looking at connecting up rigid groups. So rigid groups are basically the parts that will move relative to one another, and you can see from a left to right workflow, it tells you to start with grounding different parts, putting them into rigid groups. So let me create rigid group 1 here, and what we will see is that this piston also works and moves relative to the spacer. So I can create a rigid group there, and I can do the same with this part and that spacer. So what we're telling it is, with rigid groups, this is how they're all connected up. We know for a fact that this part will move relative to that spacer on the inside, as well as the other parts. So we know that this whole, these 3 different parts will move as one unit. Now once we've done that, it will then tell you to put in some joints. So joints is basically how we're going to dictate the different parts and how they would move relative to one another. So you'll see between these 3 parts here, the spacer and the 2 brackets at the side, it's detected that, they've got aligned holes, and what we can do is put a pin joint through them. So we can specify a pin to go through them because that's how they're connected up. We can also start telling it to look at cylindrical pairs as well. So we can tell it to search for itself. So if we do, so we can change the auto search distance as well to look for different connections. And you can see it's picked up a cylindrical joint between these 2. So we will know for a fact that this shaft here will move in the vertical, in and out of this piston here in a cylindrical manner using a cylindrical joint. And last but not least, what you can also do is start looking at the single holes. So where we have single holes, this is also where we want to hold it in its design space. So that's where we put a grounded pin because they're free to rotate around that part, but they're not free to translate anywhere else. Hence why our model will be grounded through that aspect there. So once we have all of these defined, we can then take it through and specify exactly how it's going to be moved. So obviously you can put on any sort of couplers where the rotation and translation of parts are moving with relative to a ratio between one another. You can add in a motor. So if you want to apply any sort of rotational movement, actuators would be what we'll be applying here. So an actuator is different to a motor in that actuators do, they implement a translational movement, whilst motors implement a rotational movement. So with this actuator here, I'm going to apply it at the end of this part here. You can see very quickly that you can then give this actuator all of its different properties. And say if I was to move this upwards in that manner, Either I can tell it to drive it using displacement, velocity, acceleration, or force, and you can then dictate the motion which you drive that force to. So either you can start looking at a ramp function or step-to-12 step, or maybe, a sinusoidal manner as well. But say if you have tabulated data, you can always bring in tabulated data in this manner. So if I go on to this area and bring in some data in this aspect, you can see I brought that all in. Now I can easily change it to millimeters just to see if it makes sense, and you can see, we're telling it to move at 13 mils, which all makes sense. And obviously you have the tabulated data for how long it goes on for. We can then also start specifying a spring. So if I wanted to hide off this part, you'll see that within Inspire, it's really nice in that it's got a geometry feature recognition tool, where if you were to hover over any sort of parts, it will show you where the center points of those parts are. So you don't need to go through and go back into CAD to specify, where the center points are. We can easily specify the center point of that to being connected to the center point of here. And then obviously we can go through and specify any sort of spring properties. So we can tell that to be 1,000 in terms of stiffness. The damper itself, we can make it 2,000. And then we'll bring everything back. Obviously, we need to make sure that gravity is moving in the right direction. And if you did want to specify contact or any sort of initial conditions of velocity, you can do that as well. Now, with analyzing motion, I can specify 2 seconds, and the output rate would be the amount of data you want per second. We'll just keep it to 30 for now. And very quickly, I always make sure that it's telling me to animate while solving, because if it's going to fail, at least I know it fails immediately. But then if I was to run it, you can see it solving in live time, and you'll see that I forgot to specify a very important part to maintain coaxiality around my actuator. But now that that's set, we'll be able to see that the part can solve itself quickly. So I've probably just specified something incorrectly in my joints here, but with the same setup, you should be able to see that it will just run the same way as this aspect. And like we said, after you've run all of this, if you were to click on any of your parts, you can very quickly right-click and look at the differences between the results that you get. So you can look at the part displacement, the velocity, and the acceleration. Within your joints, you can see the maximum joint forces. But what's really nice is that if you were to right-click on any of these graphs, you can just take it through to analyze. And you can analyze the part, or you can optimize it. And it'll only take a few minutes to run. You don't need to do any of the meshing yourself. It'll automatically do a mesh for you. But what you will get at the end of it would be, say if you conducted an FEA analysis, we'll be able to see the stress contours on it in this manner. And then obviously if you conduct an optimization, you'll then also be able to see how it optimizes. So if I was to look at the stresses on this part itself, or let's look at the von Mises stresses. And if you were to click play, you can see exactly how your stresses will vary throughout the animation itself. And then to take it one step further, if you were to optimize it, you can see after you've optimized it, it will show you exactly where you can take material out of your part in this manner. So if you did want to follow this tutorial on Altair University, you can download the model and you can go through the same the walkthrough of the mock-up and how to put this whole model together. And yeah, do give it a go. It's super easy to use and it's very user-friendly. If I can just get back to my slides now. So within Inspire Motion, obviously you have the force exploration tool. That's what you would use to look at the torques and the forces required to go through it. Like we could see, there's a seamless transition into analysis on the part. So to take it through from conducting the MBD analysis to looking at FEA. And then consequently after that, you can conduct optimizations on it. So you can see that the setup was all done for you. The optimizations that you can do can vary from topology to gauge. So you're not limited in any sort of, optimization methods. You can do a thickness optimization, or you can look at topology to look at the stress load path. and it takes it all through for you. So you don't need to go through and set up the model, countless numbers of times. You can conduct a topology optimization that's been derived from a multi-body dynamic analysis. It uses MotionSolve in the background. So like we said, just because it's so much easier to use, by no means does it mean that, it's less accurate. It's just as accurate as it would be if you were to use MotionView. And you can also export model and animation data very easily. So you'll probably see back if I just bring up that screen very quickly. At the bottom down here, with these settings, you can see you have a record button down here where you can record animations, and you can either export it as an MP4 or as a GIF. So yeah, so let me pass this back to Andreas, who will then take you through the sponsorship details.
Thank you, Joyce. That was amazing. Thank you for showing everyone how to run through a multi-body analysis in MotionView and InspireMotion with MotionSolve. So now I'm just going to run a little bit through the Altair sponsorship and what we can offer you. So from our side, what we'll provide to you is access to the HyperWorks suite. So all the tools that we have available, you will get full access to, and this is the industry standard edition. So this isn't a student version. There are no limitations to the model size. This is the exact same thing as gets provided to industry. So you'll have the same functionality as you would experience when you're a graduate. When it comes to licenses, so we'll start off with about 10 initial licenses worth roughly around £250,000. But I mean, to be honest, we're more than happy to cover enough for Class 1 and Class 2. So all you got to do is let us know roughly how many people in the team would like to use the software, and we are more than happy to cover, whatever that number may be. But we just say 10 as the start, but we're always happy to have a call with the team, discuss what your requirements are, and we'll make sure that everyone in the team has enough licenses to do the work so that you never run out. When it comes to resources, because we know that learning a new set of software will take a little bit of time, we'll try and make sure that there's enough resource in place for you to pick up the software as quickly as possible. So we've got the Altair University webpage, and on this you have things like webinars, ebooks, self-paced learning courses. The Altair University even has a YouTube page. So most of the stuff recorded on the Altair University website will also go onto YouTube, and this includes sort of half an hour long, hour-long demos of InspireMotion for composite optimization, for topology optimization, for CFD. These sort of in-depth, step-by-step videos are included on YouTube. Marketing-wise, so we'd always love to do a case study with you. Anything you're particularly proud of, you've always just got to let us know, and we can come up with a case study for you to take to graduates and to share around, etc. Success stories are always fantastic to have, as well as social media. So if you're on Facebook, Instagram, Twitter, just hashtag Altair University and show off your best work, and the Altair University account will repost that. Other things that we do are events. So we have an Altair technical conference held for someone from academia to come and speak at, or at least speak to people that attend these events, speak to industry, show off your best work. We have an Altair academic event ourselves, and that's a better opportunity for academic customers, prospects, etc., to come and discuss the work that they're doing and how beneficial using Altair is for their curriculum. And we like to get teams to come in and present. So recently we've had Oxford Brookes present at one of our European webinars. So the best way is just to show off the most fantastic work that you've been doing, and that gives us the fuel to get you involved in these events, because we want to make sure that you can get the most out of the sponsorship. In terms of really what we asked from you, really just a logo. So a logo on the car, and if you do have team clothing, a logo on that too. Social media wise, again, just a post here and there, just to show off some of the work that you've been doing, and have us included on your website as well if you have one. And again, case studies, just anything that you're really, really proud of, we're happy to create an Altair case study for you. In terms of sort of the sponsored teams we're at the moment, we have the likes of sort of Team Bath Racing, Oxford Brookes, Surrey, Loughborough Motorsport, Manchester Stinger, etc. And they've been doing really some incredible work so far. with topology optimization of uprights, teams already adopting the multi-body dynamics analysis and CFD as well. The list continues, and we're more than happy to sponsor basically anyone that gets in touch. It's really just something really exciting for us, and we're happy to get everyone involved. And obviously, for the former student community to sort of share ideas of what they've been doing with the software, because, having been part of former student myself, I know how keen teams are to sort of share the fantastic work they've done. And obviously, you've got these teams here to sort of help you with that already. So now I'm briefly just going to boot up a couple of polls. So bear with me 1 second. Just going to start the first one. Okay, so hopefully you should have a poll on screen. I will leave this up for a couple of minutes. So in about 10 seconds, I'm just going to close the poll. I hope you've been able to see it. So in about 10 seconds, I'll close it off. Okay, so we're just going to close that one off, and we have just one more for you. Okay, so I think that one worked. Okay, and we're just going to start off one more poll question for you. So this should appear in a second. Okay, so the next poll should be up. So I'll leave that again for another minute or two before we head on to the Q&A. Okay, so we're just going to close the poll now. And I think we will move on to the Q&A. So yes, so we have a few questions in already. So I'm just going to have a scan through these, and I'll put these to Joyce. If anyone has any questions about, obviously, MotionSolve, multi-body dynamics in particular, please fire away, or any questions about accessing the software or the sponsorship, etc. So I'll just run through some questions. So one of the questions being, so So one of the questions we have here are, what are some of the features of Altair's multi-body dynamic solutions?
Right, so hopefully that question, what are the features of MBD, hopefully that was covered in the demo and that you had a good understanding of it. If not, you're welcome to contact us separately after this and we can go through it again. A second question was what kind of materials used for this? So you can use any material based upon what it is that you're looking at. So in MotionView itself, there is a material database, and obviously if you assign your parts to being steel or aluminium, it just uses the density of that material to find out the mass of it. And then obviously when you want to start incorporating flex bodies, they can be any material you like.
We have another question here so does Altair provide courses and or certificates for MotionSolve?
Altair do provide courses and certificates for MotionSolve as well as Inspire Motion. So in terms of if you go on to Altair University, you can apply for an account there. There's some self-paced certification courses on there where if you go through it, you can get certificates for what you do. So if you just want to go on to Altair University for the training section, then yes, once you complete those courses, you can be self-certificated. Another question that we have, please can you explain us again how we apply springs or other parts? Yes, so in terms of the thing that I just did, so if I bring this model back up, now when you attach your different parts, obviously it's just running through and seeing exactly how it is you can attach it. So like I said, within Inspire Motion, it's got a geometry feature recognition tool. So what you can do easily is, say if you want to create a spring, you can either create it where it's just a spring itself or a spring and damper system. And if you were to just hover over different aspects, then you can see if the center pops up for this circle here, then you know it's the center of that surface, and you can attach it to the center of this one. And then straight after that, within the micro dialog box, you can go through and specify your spring damper coefficients. So you can give it a spring stiffness or the damper stiffness, and you can go through and set it up this way. Another question, how to obtain educational license. So it depends which one you want. So if you want the student version, you can easily access Altair University. And within the Altair University, as long as you register with your academic email address, then you can obtain a student version outside of the UK. So you're welcome to try that. And obviously, if you are interested in using us as a teaching package, just contact your local Altair office and they'll talk to you about the educational side.
Another question here. So is it possible to insert suspension data from data acquisition systems in a CSV format in order to compare theoretical versus actual data?
Yes, you can. So when you want to insert data acquisition data itself in a CSV format, you can see itself when you insert it in within the results. You can see the actual result versus the desired result, and there's differences between the two graphs, which you can then look at, using the optimization wizard to perform the way in which you would expect it to.
Okay, so we have a question here just asking about a point of contact so that they can initiate the process of sponsorship. So what we will do just on screen is we'll put down both our email addresses. So if everyone could just keep an eye out on screen, and then we'll type in both our email addresses, and please feel free to contact both of us about sponsorship, and we'll typically organize a call with the team first, just to meet everyone, see what you're looking at doing with the software, and if you're happy with the sponsorship. And from that point on, it's really a matter of sorting out the licenses. As you can see on screen, I have quite a long name, but the @uk.altair.com is both the same. So we'll leave that on screen. Those are the email addresses if you'd like to get in touch with us about sponsorship. Okay, so the email addresses will disappear in about, well, now. So we'll run on to some other questions, but we'll just include it on some slides. So bear with us 1 second. We'll add them in for you so that they stay there permanently. Again, my long name taking its toll on PowerPoint. Okay, we'll head back to Q&A. Okay, so next question is, so can we import CAD models from other software like SolidWorks? If so, what are compatible ones?
Yes, so like Andreas was talking about at the very beginning when we said open architecture solutions, you can bring in CAD data in its native CAD format from any sort of CAD package that you have.
Okay, another question being, so will the webinar be available afterwards? The answer to that is yes, you'll be able to get a recording after the webinar. Another question being, so can Inspire Motion simulate gears, say a planetary gearbox for a former student electric vehicle?
Yes, it is. You can simulate gears. All you need to do is just specify exactly how it's connected to the rest of the model up and the contacts in which it comes into with the other parts.
Okay, another question here. So once an optimized geometry has been created, can it be exported as a CAD model? How is this intended to be used as a reference for improving the original geometry? Is it simply a case of making a new CAD model with the main load parts included?
Oh, this is a big question. Very good question. So once an optimized geometry has been created, can it be exported as a CAD model? Yes. So within Inspire Motion, let me bring that back on screen. Any sort of optimized model that you have, you can easily look at, putting polyNURBS back onto it. And what polyNURBS does is it converts any sort of STL or mesh files that you have into a proper CAD. So like a dumb solid model that you can easily take into CAD to draw up properly with a CAD history tree. How is this intended to be used as a reference for improving the original geometry? So obviously based upon the optimization that you do, if I can show you the optimization options that you have, when you have something that's been analyzed, and say if we want to take it through for an optimization, obviously based upon what it is you're trying to achieve in your optimization itself, are you looking at maximizing stiffness, minimizing mass, maximizing the frequency? These are all of the different objectives that you can go through, and the optimization type you can also change. So if we're looking at a topology optimization, what we want to do is understand where our main stress load paths are, so which part of our designs are used most, and where our redundant material is. And obviously where redundant material is, where there's no stresses touching, it effectively means that we don't really need material there. So that's where we take material out of it. So you can look at taking material out of it while still stiffening that part up, and you can give it a mass target design. So that's probably, how it's intended to be used, where you can improve from its original geometry. You can make it lighter and perform even better than it was before. So, I hope that answers your question. Like we said, you have our emails, so if you want to go through it a bit more, do feel free to contact us at any time.
I have another question here. So can we analyze different types of suspension systems like a double wishbone suspension system?
Yes, you can. So like I showed within MotionView, within that assembly wizard itself, you can specify the different types of systems that you want to use for your suspension systems. So you can specify if it's just, using front struts or with a stabilizer bar. You can there, yet again, look at a double wishbone suspension system, should you like.
Okay, so we don't have any fresh questions at the moment, but I think we have a few more minutes. So if anybody has any questions, please feel free to ask away now, and we'll answer them as they come through. So we'll be here for a few more minutes.
Just wanted to say though, looking at the poll results, it's awesome to see how many of you guys want to, use it for multi-body dynamics, for FEA, for CFD. It's incredible, and obviously this tool set is something that you guys will take with pride once you graduate from university. I know how much OEMs love seeing this, seeing the skill set that you guys have, and using the same software that they're training up to use as well. It'll make you guys so employable. Incredible.
Okay, whilst we're sort of waiting for a couple of questions, we'll just also show you the Altair University webpage. It's quite literally, you can Google Altair University, or it's just altairuniversity.com. So we'll just bring that up on screen in a second. So yeah, what you can see on screen here is we have a blog, so you'll see sort of introduction to the webinars that we host, where you can find videos from that. There is sort of the student portal, where if you wanted the free edition, which is limited, so naturally if you get in contact with us, we'll be able to provide you with the unlimited edition. But here you can get the ebooks, you've got the online learning and certification courses. We can go into the learning library and we can find webinars, videos. You can see here on screen the two people talking right now. So I've got a video I can see from the poll that sort of 20% interested in CFD. I have an hour-long video for external aerodynamics, so a step-by-step process using our tools. Then again, there's another video of Joyce running the MotionSolve analysis. There's optimisation with Inspire using SimSolid. And if we go onto the Altair University YouTube page, so give us 1 second. So on that is, again, just a way of accessing more of the videos as well in sort of one neat area. So we'll just head on to the YouTube page. Here we go. So go to the videos. We can see here that, so we've got plenty of SimSolid videos for using Inspire Studio for design, optimization. If we keep on going, we'll start to find some more complex things. So like there's hour-long videos on composite optimization of a former student chassis. That's one of the videos in there. Quite detailed analysis of using motion for a Baja vehicle, for example. So there's plenty of competitions that we're part of. And all this information, all these resources are available online for you to pick up the software as quickly as possible. We know it's a challenge to learn something new and to learn a new set of software and to move away from another one. So we want to make sure that it's as easy as possible for you to pick up the tools. So please head over to the Altair University website and the YouTube page to basically give you that helping hand to pick up the software as quickly as possible. Again, certainly I believe it's helped out, a few of the teams that we're sponsoring. So certainly, again, examples, Brooks, Team Bath Racing, Surrey, Manchester Singer, all using these applications to help them pick up the software as quickly as possible, and they have now adopted it. So again, it's nice to see sort of Team Bath Racing picking up MotionSolve for their analysis. We've got Surrey picking up CFD and MotionSolve 2, or I think new users of the tools over the past couple of years. So just a testament to what you can actually access online and how it can help you pick up the tools as quickly as possible. Okay, so we have one last question to close off. So someone is designing an autonomous wheelchair. Can the software be useful here?
Absolutely. So it depends on which aspect of the autonomous wheelchair that you want to design. Whether if it's looking at the system performance of it, you can use Activate and Compose to dictate exactly how it should behave when detecting, obstructions in front of it. If you want to start simulating the communication system behind, the communication systems of it as well, you can start looking at our electromagnetic solvers for flux or FICO, whether if you're looking at high frequency communication or low frequency as well. And obviously if you're looking at the structural analysis of it, we have OptiStruct and Radios. If you're looking at explicit, so if you're in event of it, being damaged, you can look at explicit software for it. If you want to look at the streamlining of that wheelchair as well, you can use our CFD solvers for external aero. And obviously, all of the different solvers can be coupled up. So if you want to look at the external error of it with regards to how it's moving, varying over a certain time period, you can couple it all up so that you can get the right design that's robust enough to handle anything that you throw at it. So, yeah.
Awesome. Thank you, Joyce. I think we have arrived at 1 o'clock, so I think we will call the webinar there. Thank you very much, everyone, for joining the session. I hope you found it really beneficial, and I hope you could see some opportunity in using Altair software. Again, I hope on screen you've got our email addresses if you wish to get in contact with us. And especially for the sponsored teams, our plan of action is to typically just have a call with the team, meet everyone, see what you're interested in simulating, and we'll get you kitted out with the software as soon as we can. So yes, thank you everyone for attending the webinar. I hope you enjoyed it.
Thank you guys. See you all soon.